Good evening, Aini. Shivavni, good evening, beta. Nandini, good evening. Abhirami, Madhumita, Shivatsan, good evening, beta. Shivatsan, good evening. Good evening, everyone. Fine. So first, a small recap we are going to do. Okay. First, a small recap we are going to do. Based on that recap only, we are going to study from the last section. First section we are going to study. Okay. Actually, 3 PDFs are there. Today, periodic classification period. This PDF will be available to you. Yes, beta. That was we have discussed. But let's see some recap. I am going to take. Let's see. Fine. Just 1 minute. Some adjustment is needed. Okay, beta, screen is fully visible. Screen is fully visible to you. Okay, now listen. Kamya, good evening. I'm just waiting for children to join as fast as possible so that I'll start asking some questions based on periodic classification. Okay, Kamya, because now heredity part is only left, and heredity and evolution. After that, already revision panel is going on to discuss that also. Okay, fine. Now first question is, atomic radius increases down the group. Statement is true or false. You have to listen to my statement and then you have to answer the question. Atomic radius increases down the group. Statement is true or false. You have to respond as quick as possible. Atomic radius increases down the group. Statement is true or false. Atomic radius increases down the group. Statement is true or false. Atomic radius increases down the group. Statement is true or false. Quickly say. Atomic radius increases down the group. Statement is true or false. Means false. Akshaya, false. Tawfiq, true. Akshaya, true. Tawfiq is telling true. The correct answer is true. The correct answer is true, and you know the reason that when we are going down in a group, the addition of new orbits will be there, and due to addition of new orbits, what happened? First, screening or shielding effect will be there. Nuclear charge will be increasing, but taking out electron from the outermost orbit will be easy. Taking out electron from the outermost orbit will be easy. That is not defining, but the electron cloud will expand when going from top to bottom. So 100% atomic radius increases down the group. Atomic radius increases down the group. This statement is absolutely true. Well done, both of you. Next question. Next question. Which is the most electronegative element in the periodic table? Which is the most electronegative? Sarthak, good evening. Start answering questions. Quickly answer the questions. Which is the most electronegative element in the periodic table? Most electronegative element in the periodic table. Most electronegative element in the periodic table. Most electronegative element in the periodic table. Yesterday itself we have discussed about this point. Most electronegative element in the periodic table. So yesterday I have discussed all these points. Okay, I received Kamya's answer. Let's see what others have to say. Which is the most electronegative element in the periodic table? Most electronegative element in the periodic table. As Kamya has given the answer, fluorine. Let's see what others has to say. Okay. Tawfiq, fluorine. Yes, the correct answer is fluorine. Why this much time is going on for just answering the question? Because yesterday itself we have discussed among lithium and cesium, which is the most electropositive element. Among lithium and cesium, which is the most electropositive element? Quickly answer the question. Among lithium and cesium, which is the most electropositive element? We have to start today. Again, the most important point. So last 2-3 questions I am going to ask. Last 2-3 questions I am going to ask. Start answering the question. Which is the most electropositive element? Lithium or cesium? Lithium or cesium? Which is the most electropositive element? Lithium or cesium? Lithium or cesium? Lithium or cesium? You all are not listening me. You all are not listening me. You all are not listening me. What did I said about electropositivity? What did I said about electropositivity? I said about electropositivity, the tendency to lose electron. The tendency to lose electron is relative to electropositivity. Akshay, well done. Is it happening for everyone? My voice is coming after some time. Is there any gap? You are not listening to me. Again, beta, you go out and again join that. Sometimes because of yes, cesium is absolutely correct, Yaini. The correct answer is cesium. See, when you are framing the answers in your brain, they will give you not one question from periodic table. They will give you one package of question for 4 mark. 4 mark question will not be a literature question. 4 mark question will contain 4 points. Many years I am seeing they are not giving a 3 mark question. They will subdivide the question. They will subdivide the question relative to the topic. So please don't do this. First thing is that we discussed that lithium, you have to understand one thing. Again I am discussing. No confusion should be there. Kamya, anyone, there should be no room for confusion for this point. Now listen, again I am telling you, listen to the point very nicely. See, lithium to cesium in the periodic table. Check this one out. We know that the S1 block is only responsible for electropositivity. Extreme right of mine, they are exactly what question? Nitin, good evening beta. What question was there? The question was, which is the most electropositive element, cesium or lithium? Which is the most electropositive element, lithium or cesium? Which is the most electropositive element, lithium or cesium? The answer will be what? Lithium or cesium? most electropositive element. So answer is cesium. The reason behind is among lithium and cesium, if they will tell you to compare, then you can say that what is electropositivity? The tendency to lose electron is electropositivity. How easily an element can lose electron, that much that electron can be, that much that element will be strong electropositive. Then you will say that, auntie, from here to here all will be exactly, can only have to lose one electron. Yesterday I told you the story about oxygen, that oxygen has to exactly release 2 electrons, and due to release of 2 accept 2 electron, due to acceptance of 2 electron, first it will accept 1 electron. After that nuclear charge will exactly become more effective and electron-electron repulsion will be there. So since electron-electron repulsion will be there, it will create problem for addition of new electron. That was a very important point I have discussed. So if we are going to talk about, oxygen example I have taken. Now look here, I am going to talk about magnesium and magnesium and sodium. So look here, the one magnesium will be exactly releasing 1 electron. So nuclear charge will become effective. So since nuclear charge will become effective, so it will not allow the release of 1 more electron so easily. It will not allow the release of 1 more electron so easily. So since it will not allow release of 1 more electron, so electropositivity decreases from left to right. I repeat, electropositivity decreases from left to right. Electropositivity decreases from left to right. Electropositivity is exactly decreasing from left to right. That is, metallic character will be exactly decreasing. Electropositivity means metallic character. So metallic character decreases from left to right but increases from top to bottom. So electropositivity increases from top to bottom. Electropositivity or metallic character, what word I have used? So there should be no confusion there, beta. Electropositivity or no Akshaya, don't see the 7th group, radioactive element. No, don't see that. Francium, don't see that. You have to stop to cesium only. You have to stop to cesium. The most ideal one will be cesium. Okay. So that is what electronegativity increases, but beta atomic metallic character or electropositivity decreases on going from left to right in the periodic table, but on going from top to bottom in the periodic table, here francium will be there, above cesium will be there. So we are only going to compare cesium. Okay, we are going to check for cesium beta, and that time among lithium and cesium, since electropositive character increases down the group, so among lithium and cesium is having the apt ingredient to become more electropositive. First, its bigger structure, then inside orbit shielding effect will be there. That is also one of the things responsible for making it most electropositive. So beta, this confusion should not be there. Reason also they may ask in CBSE. They may ask among lithium, they will give you 3 elements. Okay, most probably they will give you the successive 3 elements and they will tell you that identify the one which is more electropositive. The next successive question they will ask, why the selected element is more electropositive. That time you have to reason behind its electropositivity. That time you have to, yes, bigger radii is one of the answer, Kavya, super. So I want everyone to precisely answer the question. When periodic classification is exactly involved, you have to write answers to the point. They will not entertain you with wrong answers. I am telling you. They are not going to entertain. Last time you have given MCQ examination, that time true or false like statement was there. But this time you have to write statement. Now you are going to write first board examination where you are going to write answers. Presentation of answers counts a lot in CBSE. From many years I am seeing very good students are not getting good marks. And the one who present nicely, hydrogen don't contain beta. Hydrogen don't contain because hydrogen have anomalous behavior. Anomalous behavior means they behave electropositive also, electronegative also, Sudarshan. Because of this anomalous behavior, we see that hydrogen electropositivity character is far away from lithium to cesium. Understood? So that time they will be asking this question. That time you have to be very smartly answering the question, Sudarshan. Now go for the next point. I was discussing about this chemical reactivity. Now yesterday I talked about reactivity. Come on, quickly type me or type the content to me, that on going from left to right in the periodic table, how the chemical reactivity behaves. How the chemical reactivity behaves on going from left to right in the periodic table. If you are taking periodic classification easily now, then in examination you are 100% going to get stuck, because they will be asking everything. Here it is just like literature. Here you don't have to give your point of view, because whatever point of view is set, you have to write that point of view only. Means if it is possible that it is due to shielding effect, means you have to write shielding effect. You cannot write any other thing there. You have to mention the key point that shielding effect is reason behind it. Okay, now I am asking the question. Good evening, Rahul. Where is Mohan? I'm just waiting for the day meeting you all. Seriously. The day I'll start revision now, oral revision. You see that day what I'll do. I have that stick ready with me. Now come on, start answering the question. Okay, no problem, Rahul. Start answering the question. Now, next important question I've asked about reactivity. Let's see who is going to decrease then increase. Absolute, Akshaya. So it's exceptional. Is exceptional? No. Sudarshan, you are talking about which one? First tell me, are you talking about reactivity, chemical reactivity, or you are talking about hydrogen? Okay, come on, quickly answer the question. Akshay, that was a smart move. Reactivity first decreases and then increases. Is this statement true, or reactivity increases and then decreases? The correct statement Akshay has given, and that is the question is, what happens to the chemical reactivity when you go from left to right in a group? What happens to chemical reactivity when you go from left to right in a group? Very good. Okay, hydrogen, Sudarshan. Now quickly answer my question, Sudarshan. I want to know this answer. So Sudarshan has given the answer. It is going to decrease and then it is going to increase. So let's start with chemical reactivity. Okay. So last class I had just given an intro to chemical reactivity, because this is a very important topic. Based on chemical reactivity, many questions in future you will be seeing. So I'm just preparing you today itself. It decreases, correct, Rahul? So now look here. On going from left to right in a periodic period, the chemical reactivity of element first decrease and then increases. I wrote to the point so that you don't have to write here and there, just write the first point. Now I have exactly selected third period. Why I have not selected second period? At the time of revision I will say you. Okay, good evening, Sharan. So now I am just going to take that sodium, magnesium, because I just wanted the collection of most reactive element, and the most reactive element is sodium. You know that sodium is there, potassium is there. So my collection, I just took that third period where I am just going to go for the most reactive element. So most reactive element, sodium I have taken. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. Now you see here, automatically you itself will say that auntie, sodium is most reactive, auntie, and after that magnesium will be there, auntie, then aluminium. By seeing sodium itself you will say that sodium is most reactive, and then you will see chlorine, and then you will say, auntie, you know what, chlorine na very reactive, auntie, because we are seeing that chlorine forms acid. So chlorine is also very important element, auntie. That's why I have selected, so that in examination you can pick this group period and write in examination. And you also know one very important thing, that silicon is metalloid. Now silicon is least reactive. Silicon is least reactive. Okay, so that means selection of third period, I think I told you now only why I have selected the third period, so that at the time of writing your analyzing power will be reflected very clearly. Second thing is that ki everyone knows, means the person who will be correcting your paper, he or she will be exactly quite sure about sodium and chlorine and silicon, and so only I have selected third period to represent reactivity, because it will give clarity about the concept. Okay, so sodium is most reactive because it can release electron, easily. But releasing electron from magnesium side is quite difficult, because magnesium has to release 2 electrons. So that story what I told yesterday, that is going to be the reason behind, that is effective nuclear charge. Nuclear charge remains the same, but electrons are exactly taken out from the outermost orbit. For magnesium, magnesium has to release 2 electrons. So magnesium has to release 2 electrons. So now from outermost orbit, if magnesium will release 1 electron, then the nuclear charge remains the same as it was in the previous case before releasing this electron. If nuclear charge was 14, then the nuclear charge is 14 again, but here electron out. So now only 14 nuclear, same 14 nuclear charge, but electron number is less. So that means now the nuclear charge is more effective. So it will not allow the release of another electron more easily. So when someone stops your way of progress, that means what? Your progress will be stopped. So here also something stopped the release of another electron. That means it is not that much reactive as sodium is. It is not that much reactive, okay, as sodium is. Fine. Then aluminium has to exactly release 3 electrons. Silicon has to release 4 electrons. So which is exactly going to be very problematic case. So that's why we have exactly taken silicon. Now phosphorus has to accept 3 electron. Accepting 3 electron is also a problem. Okay, so when you will take 1 electron, nuclear charge will somewhat balance the presence of electron. But when you are accepting the second electron, the outermost orbit, when you are taking electron, that time the electron repulsion will start, because the cloud of electron will become more in the outermost orbit. So this repulsive force has to be overcome by nuclear charge. But nuclear charge is same and electron addition is going on. So because of that, taking 3 electrons is quite impossible. So they will be sharing electron. Okay, because of this reason we can say that phosphorus is not that much reactive as sulfur and chlorine. But sulfur and chlorine, nuclear charge can withstand 2 electron acceptance, and 1 electron acceptance is the golden opportunity. So this is exactly the point. Yes, Saptal, just contact me. I told you, you give me your phone number. I hope you might have understood. Come on, quickly give me the point. You have understood or not? Quickly give me, you have understood this reactivity. Same reactivity explanation I need. I need same reactivity explanation. I don't need here and there. Good evening, unknown. So now explanation point. Now I am going to discuss the explanation of it. The valence electron of sodium can be lost easily for reacting with other element. The element magnesium has 2 valence electron. It is not so easy for an element to lose 2 electron. So magnesium is less reactive than sodium. Similarly, aluminium, silicon are still more unreactive because they have 3 and 4 valence electron respectively, which is difficult to lose. But silicon onwards, the chemical reactivity increases. So I just wrote the silicon onwards chemical reactivity. Okay, Saptal, I'll take this one. Okay, fine. So now we are going to talk about next point. Next point, till here it is effective nuclear charge increases across a period because force of proton is greater than electron. So metallic character decreases across period. Correct, aunty? Yes, I can take your point. I can take your point. I think I have not taken that point. One person is there who is exactly okay. I hope you might have understood this point. Understood this point, yes or no? Come on, tell me. Then we are going to talk about chemical reactivity exactly related to period. Chemical reactivity period wise. Chemical reactivity period wise. On going left to right in a periodic table, the chemical reactivity first decreases and then increases. Already we know, okay? And now I think we are exactly going to talk about explanation, continuation of that. Phosphorus has 5 valence electron and hence need 3 more electron. Sulfur has 6 electron needing 2 electron, which is exactly and chlorine is exactly having 7 electrons, so it is needing 1 electron. Since it is comparatively more difficult to gain 3 electron than 2 and 1, so chlorine is higher reactivity than sulfur, okay, and phosphorus. So this explains the above reactivity. I hope reactivity part is now okay for you. I hope reactivity part is now okay for you. Come on, quickly give me a nod that reactivity part is over. Reactivity part is over. Come on, quickly tell me that chemical reactivity along the period you have understood. Chemical reactivity along the period you have understood. I am coming to your home, Mohan, today. Last part, okay, Kavya. Now listen, beta. Last part, Kavya, what is exactly there? So last part, beta, I am going to explain one more time. So last time, I am repeating this point that beta, chlorine has to release only 1 electron. Just one time I am going to explain this one. Chlorine has to accept only 1 electron. Chlorine has to accept only 1 electron. Sulfur has to accept 2 electron. Phosphorus has to accept 3 electron to complete its octet rule. So since accepting 1 electron in the outermost orbit is easy, so that the nuclear charge is going to counterbalance this part. So, but accepting 2 electrons and 3 electrons is quite difficult, because you know that when electrons are getting added in the outermost orbit, then electrons will have repulsive force. See, usually you and Akshaya is there, and I am supposed to talk to only you and Akshaya. Understood, Kavya? Now Sudarshan also joined with me. Now we 3 are talking, but with Sudarshan, Mohan also is there. So now we 4 are talking. With Mohan, I started talking to Rahul also. So that means now my interaction is with these many children. So I won't be able to answer everyone at one time. So what will be the problem? You all will have repulsive force. Auntie, why you are not answering my question? Auntie, why you are not answering my question? That means this is exactly called as repulsive force. So this repulsive force between electron. So they will not fight with me. They will not fight. So electrons are not fighting with the nucleus. Nucleus is binding these electrons. So nucleus cannot fight with electron. Exactly, electron will start fighting. So students will start fighting. Hey, why you came here? I was talking to auntie, and auntie, you disturbed our talk. So like this they will start repulsive force. So that means what? So when we have to take 3 electrons, the electron, when 1 electron taken, okay, accepted, 2 electron taken, now nuclear charge is same, but extra electrons are added. So what happened? I am same, but extra person are coming and talking to me. So my attention will exactly get deviated. So because of that, what will happen? The repulsive force between electrons will increase, and this will hinder the reactivity. Kavya, I hope you might have understood this point. Yes, more valency, that is what the shortcut point, Mohan, absolutely correct. In shortcut, what Mohan has said, that is also correct. Less valency means needing, combining capacity. If combining capacity is less, means if I am needing less, means I am more reactive. Okay, if I am needing less, means I am more reactive. If I am needing more, I am less reactive. Super. So now we are going to talk about chemical reactivity in a group. Now one question is there. I have told you one story when I started the periodic table. That time I told chemical reactivity exactly remains same along a period. chemical reactivity remains same along a period. This is a statement I have given you. If you remember, chemical reactivity remains same along a period, remains same along a group because of electronic configuration. Same valence electron will be there in the outermost orbit. Because of that, exactly the valency is same along a group. The valency is same along a group. Because of that, they will have same reactivity. I have discussed this one. This point I have discussed. But now we are going to create a change in the concept. And now what change in the concept we are going to do? Please don't do any massive change, because the concept is overall chemical reactivity remains same. But we have to check the electropositive and electronegative elements. So see here, lithium, sodium, potassium, rubidium, cesium. So now which one is most reactive? Among the group, if we have to check, see, all are exactly having same chemical reactivity. But when we go down the group, the reactivity exactly increases. The reason behind is what? So the reason behind is the bigger size, addition of extra orbit. The reason behind is shielding or screening effect. The reason behind is shielding or screening effect. Then you will say, auntie, why you are talking about shielding or screening effect? Then you compare the size of lithium and cesium. Come on, tell me, whose size will be more beta? When you are comparing the size of lithium and cesium, whose size will be bigger? Absolutely. So now if bigger size will be there, very good Akshay. So if bigger size is there for cesium, that means inside inner orbit electrons will be there. So these electrons will create shielding effect. Now what happens? Taking out electron from the outer orbit is easy for lithium or cesium. So if I want to steal one electron from the outermost orbit, from which one I can do easily? From lithium I can take out one electron easily, or from cesium I can take out one electron easily? Come on, quickly tell me. From lithium I can take out one electron easily, or from cesium I can take out one electron? Which one is easy for me to snatch one electron? Absolutely correct. To snatch one electron from cesium, because its structure is big. No one is there to think about it, because the outermost orbit, the electron power is there. The electron is power because inner electrons are exactly involved with the nuclear charge, but the outer electron has no affection with the nucleus, and the inner electrons are not allowing this outer electron to have interaction with the nucleus or nuclear charge. So because of that, the outer electron is exactly already in having less affection or less effective nuclear charge. So plucking that electron or stealing that electron from the outermost orbit means I will give less energy in itself, and I will take out that electron easily. So this is that concept. Okay, so now see, the chemical reactivity of metal depends upon their tendency to lose electron. I want you all to write this point. Same as electropositivity, chemical reactivity also says this point, that I will be more reactive when I can lose electron very nicely. So as we move down in a group, the metal element, the size of their atom goes on increasing. Due to increase in size of atom, the valence electron of metal atom, which take part in chemical reaction, become more and more far away from the nucleus, and hence can be removed easily. Are you understanding? Extra orbits are there. Extra orbits. For lithium only 2 orbit is there. For cesium 1, 2, 3, 4, 5, 6, and outermost orbit 1 electron is there. So that means if I want to take out electron, then I will be able to take out this electron easily in compared to that of this electron, because reactivity says that how easily I can take out one electron, that much reactive that element is. So I think among lithium and cesium, the most reactive element is decided by deciding that from which element we can take out electron how much easily. So cesium give more access to take out electron easily in compared to that of lithium. This is a very important point to discuss. Okay, so now we are going to go about chemical reactivity in a group. Now another important point, because we have discussed chemical reactivity of extreme right element, that is S1 block. Right now I discussed about S1 block. Group 1 I discussed. That means I talked about those elements which are exactly present in group 1. Because you all told me one thing, that auntie, you know, on going from left to right, first reactivity decreases and then increases. That means automatically the first group is most reactive. Okay, and the last group, last but one, that is halogen family, is most reactive. So now we have understood reactivity along the group. For such group 1 element, we talked reactivity along the group. Okay, so now reactivity along the group for S1 block means group 1. Now we are going to talk about electronegative, means we are going to talk about that time it will be problem. Now look here, electronegative element behaves differently. Here they are needing electron. You have to understand that chemical reactivity decreases down the group for halogen family. It is decreasing down. See, they are having reactivity. They are having more reactivity. This family, group 17, they are more reactive than other groups. Group 17 is more reactive than other groups, but when you will go down the group, the reactivity decreases. Are you understanding this part? Group 1 is more reactive, group 17 is more reactive. In group 1, when you go down, reactivity increases. But when you go group 17 and you go down, reactivity decreases. Then what is the reason behind decrease in reactivity? What is the reason behind decrease in reactivity? So here things are quite different. Fluorine, chlorine, bromine, iodine, they need electron. They need electron. They don't give electron. They need one electron to become stable. Fine. Fluorine, chlorine, bromine, iodine, they are needing electron, they are not giving electron. But we know that on going from top to bottom, the structure increases. So since the size increases, it is easy to give electron than to take electron. So it is also a part of the family of periodic table. Like how other sizes are increasing, other element sizes are increasing, this family size also will increase from top to bottom. But what problem will be there? Size of iodine will be big and it is exactly capable of giving electron. So how it will take electron when it is ready to give electron? That means from iodine, if I want to take one electron, I can take out electron very easily. But if I want to give an electron, so because of its big size, giving electron to iodine is a big problem. Giving electron, because its affinity decreases. Its affinity to have electron decreases. I hope you might have understood this point. Now you understood. So the chemical reactivity of non-metal depends upon their tendency to gain electron to acquire stable electronic configuration of nearest noble gas for this group. Okay, as we move down in a group of non-metal element, the size of their atom goes on increasing. Due to increase in size of atom, the distance of nucleus of atom from the valence shell increases. Consequently, the force of attraction exerted by nucleus and atom of the valence shell decreases. As a result, tendency to gain electron also decreases. So that's what now. They are willing to give electron, means I can take out electron from the outermost orbit easily. So how can I give electron and that structure will take electron? I hope you might have understood this point. This is a very, very important point to discuss. Now come on, tell me you have understood this point or not, because I don't want any fumble in this concept. This is a very weird concept, and once you will understand with these concepts, you will be able to track out the content easily. Tell me fast. Tell me fast you have understood or not. Only reactivity, think about group 1 and group 17. I want only this. Reactivity, Rahul, Sudarshan. I'm going to explain one more time, Mohan. So exactly what happened that first you have to understand that reactivity decreases from left to right and going from left to right, but again on going after silicon it is increasing. So means first group and 17 groups are most most reactivity, but in first group, as you see in group number 1, if you see in group number 1, they are releasing one electron, and they are very reactive. They release electron and they are reactive. So since they are releasing electron, and after releasing one electron they are showing that they are very reactive, so when you go down the group, the size will increase. So more size will increase, more tendency to give electron will increase, because I told you na ki as the size will increase, they will be exactly unable to take this electron, but they will give electron. But when you will go in group 17, that time what will happen? Okay, that time it will be exactly having that group 17 will be exactly doing one thing, that is ki they need electron. They need electron to become stable. But beta, as we go down the group, the iodine size will be big. So when iodine size will be big, already electron cloud is dispersed in iodine, then iodine will take one electron, very like reactivity of iodine will be less because size is big, so it will not be taking electron. So affinity for electron reduces. Electron reduces. So because of big size and nuclear shielding effect, its affinity for electron will reduce. So because of that, when you go down the group, the chemical reactivity reduces. For only group 17 I am talking about. Here reactivity increases. Most reactive is cesium, but you see here least reactive is iodine, because big size. Here they are taking, they are giver, they are donating, they are giving. So most electropositive is cesium, because outermost orbit I can pluck one electron very easily from cesium. But if I am giving one electron, fluorine will take easily, but iodine will not take, because its size is already big. It can give one electron, but it can take hardly one electron. So this is the explanation for that. Now the next important point I have added in your periodic classification, group 17. Halogen is group 17 beta. Sulfur family is group 16. Sulfur family is group 16. Sulfur family is group 16. Sulfur family, oxygen sulfur family is group 16. Group 17 is fluorine chlorine family, and group 18 is noble gas. Okay, group 18 is which one beta? Is more than electron affinity. I am going to explain about this point beta. Now valency, one Lewis law is there. So based on this Lewis law, they may ask some questions beta, but I am not expecting more questions from valency side. I am expecting more question from exactly affinity side, electronegativity side, and period reactivity side. I am expecting more questions. Every year I am seeing that they are telling particular element to decide and find that property. So there valency means, you know that element having 1, 2, 3 valence electron will show valency. So we know in the period already about valency you have seen. So I am just going to explain valency by taking a particular period. You see, if I am taking again third period, I have selected sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, then valency. There I am just explaining about valency and valence electron. So you will be seeing that electronic configuration of sodium, magnesium, aluminium, silicon will be 281, 282, 283 till 288 it is there. So number of valence electron in the outermost orbit is 1. So it is exactly going to give, share, take. So what is Lewis law? Lewis law says that, what is Lewis law? I am just explaining about yes class, tomorrow morning class will be there, Kanishka. Today evening I had severe health problem, so I was unable to take your classes, so only I didn't took the class. Tomorrow morning 100% I am going to take your class, promise. Okay. evening I will give you time for preparation. For your exam na, I'll give you time for preparation, no problem. But morning I'll take the class beta. Now down the group when I'm talking about, so can you see this? So one Lewis law I was talking about. Yes, morning maths class will be there. Morning maths class will be there. Evening I will give you time to prepare. Evening I will give you time to prepare beta. I'm sorry. Evening I'll give you time to prepare. Huh? Now look here, let me finish this chapter. Yes, Lewis law beta in between. Now what is Lewis law? Lewis law is nothing but simple concept is there. For electropositive, you have to write valency directly. Valency directly means the Lewis law says that when in the outermost orbit the valence electron is 1, 2, 3, then valency remains same. When in the outermost orbit the valence electron is 1, 2, 3, then valency remains the same. Okay, 1, 2, 3, 4, whenever you will be taking, valency remains the same. But when in the outermost orbit the electron exceeds 5, in the valence electron exceeds 5, then the rule is 8 minus 5. Means 8 minus outermost orbit electron. It will become 3. So now 6. 8 minus 6, valency 2. 8 minus 7, valency 1. 8 minus 8, valency 0. This is Lewis law. So please, Lewis law, if they will ask, then you can answer this question. What is Lewis law? Again I am repeating. Lewis law says that when we are going from left to right in the period, then the electronic configuration will be like this for period. Now valence electron, when in the outermost orbit valence electron is 1, 2, 3, 4, then write the valency as the number of valence electron. So valence electron 1, valency 1, valence electron 2, valency 2, valence electron 3, valency 3, valence electron 4, valency 4, valence electron 5, valency 8 minus 5, valency 3, valence electron 6, valency 8 minus 6, 2, valence electron 7, valency 8 minus 7, 1, valence electron 8, valency 8 minus 8 equal to 0. Come on, quickly tell me, did you understood the definition of Lewis law? Understood the definition of Lewis law, beta? Okay. Understood? Understood, Mohan? So only this one. After 4, 8 minus 5, 8 minus 6, 8 minus 7. Valence electron, 8 minus valence electron. Formula is 8 minus valence electron equal to valency. 8 minus valence electron equal to valency. 8 minus valence electron, 8 minus valence electron equal to valency. 8 minus valence electron, and this is specifically above 4. Specifically above 4. The definition says, beta, the definition says that when you go from left to right in a period, then the valency will be for those the configuration means the atomic configuration, electronic configuration, where the valence electron will be 1, its valency will be 1. Valence electron will be 2, valency will be 2. Valence electron will be 3, valency 3. Valence 4, valency 4. But when valence electron will be 8, then valency will be 8 minus 5 equal to 3. Valence electron 6, 8 minus 6, valency will be 2. Valence electron 7, valency will be 8 minus 7, 1. So like this rule will be there. But don't worry about it. The definition is here. The Lewis law is there. So this PDF will reach you. You will be able to write the PDF. So formula is also written. Sudarshan, this PDF is a complete package for you. You don't have to worry about anything. This PDF only one time you will see, you will get the formula. See here, I have exactly written the formula. Valency is equal to 8 minus number of valence electron. And definition of Lewis law is also there, beta. So don't worry about it. Okay. So this PDF will reach you. I think today we will finish. Today PDF I am going to send it to you. Now down the group. Now you have to understand that valency of a group remains same. So each group is having same valency, because you know now group 1 valency 1, group 2 valency 2, group 3 valency 3. So valency remains the same. Valency, Priyanshu, good evening beta. So valency remains the same. Valency remains the same. Valency remains the same. You have to remember this point. Valency remains the same, and it will exactly exhibit same valency. Okay. Now I am going to talk about the most awaited point, ionization energy. Now from here we are going to talk about the most important point, electron affinity, because electronegativity, electropositivity already we have discussed. Now we are going to talk about ionization energy. What does ionization energy means? First you have to understand one simple concept. Okay. Now, what is ionization energy? If somebody will be telling you that, auntie, you know what, I went to buy a pen now. So when I asked pen from the shopkeeper now, the person asked money. That means what? You went to buy a pen, the person is in return was asking you money. Quite natural now. So that means it is a game of energy. Money is energy only. Money is energy only. So that means what you did? You went to buy a pen, the person asked you money, so you took the pen, you give the money. Exchange system was there. In the same way, if I want to take electron, what I have to give in return? If I want to take electron, what I have to give in return? Come on quickly, think about the logic and say, if I want, very good Priyanshu, super beta. So energy required to make an atom into ions, super Priyanshu. That is what? So minimum amount of energy required to remove an electron from the valence shell of an isolated gaseous atom of that element to form gaseous ion will be exactly called as ionization energy. This will be exactly called as ionization energy. So ionization energy, if somebody will be asking that, in simple way you say that, like the way I went to buy a pen and the shopkeeper asked money, in the same way if I want to take out electron, I am talking about taking out electron. So I am not talking about electronegative. I am talking about the one which is giving electron. The one which is giving electron. Nothing is free in nature. Just understand this one. Nothing is free in nature. If I am wanting one electron, I have to give energy. And this energy is called as ionization energy. So if I want to take out electron from the outermost orbit of an element, then I have to give energy. And this energy is called as ionization energy. This energy is called as what beta? Ionization energy. I hope you might have understood. Gaseous atom is there, exactly present. You have given energy. Now it got converted into ion and electron release is there. An electron release. Energy needed to take electron and ionize an element is exactly called as ionization energy. That's it. Simple way. You don't have to use a rocket science there. You just have to use the basic concept there. And basic concept is buy a pen, give the money. Take an electron, give energy. That's it. So here, so magnitude of ionization energy given a quantitative measure of stability of electronic structure of an isolated atom. This is a very important point. That's why this point is there with me. The reason behind is there should be stability. See, I cannot take electron apart from the limit means above the limit, means there should be stability in the ion. So that much stability will be there, that much I will be able to take electron. I can give energy to whatever level I can give and pluck electron, but I have to see the stability of the atom also. Like sodium I need electron, I went to sodium, give energy, and sodium gave me easily one electron. Now sodium gained stability, it gained nearest noble gas configuration, sodium became stable, I got electron. I got electron, sodium becomes stable. So now this case is over. But again I went to sodium and I said that now you give me one more electron. That time I have to exactly, now the octet rule is exactly there and it is satisfied. Now this time sodium won't allow me to take one more electron from the inner orbit. It will not allow to take the, because now it is stable. So this is the most important point, that ionization energy also deals with the stability of the ion. So once you are exactly having energy, you cannot keep on giving energy and taking out electron, because every time when you will take one electron, the energy amount given should be higher than the previous one. Should be higher than the previous one. Yes, Priyanshu? Yes, beta, should be higher than the free. So this is exactly the most important point, and I am going to show you this one. Successive ionization energy means this is what is called as successive ionization energy. I have 2 electron in the outermost orbit. You came and you said that, ma'am, can you give me 1 electron? I gave you 1 electron. Because the moment I gave you 1 electron from the nucleus, nuclear charge came and holded me and said that now you cannot give more electron because my effectiveness increased. My effectiveness increased. Okay. So the case here is quite simple and clear. The case here is ki outermost orbit 2 electrons were there. I gave 1 electron. That time nuclear charge was 4. So now nuclear charge was holding 4 electrons. But now the moment I gave 1 electron, now remaining electron is only 3 and nuclear charge is 4. So now this 4 nuclear charge will have a strong eye or strong attraction with the remaining 3 electron. That time if I will go and ask 1 more electron, that means what? The atom will say that if you want 1 more electron, you have to give more energy. That means ionization energy increased. Means from taking 1 electron to going to take another electron, the stability, to maintain stability, I have to give more energy. I have to give more energy. I hope you might have understood this point. So that means we have understood one very important point, that the energy required to remove successive succeeding electron from an isolated atom is known as successive ionization energy. And now we are going to see how successive ionization energy works. Now look here. So when I am going to take, so just what is there to read? The energy required to remove successive succeeding electron, we know that is successive ionization energy. Now let's see how it is working. Explanation: metal, release of electron. 4 it is coming exactly 1, because here ionization energy first phase. Now second one, ionization energy second phase means, and this ionization energy third phase. Now where I have to give more energy? First phase, second phase or third phase? Tell me. Michael, good evening Michael. In which phase I have to give more energy? Tell me. Which phase I have to give more bribe to take out the third electron? First phase, second phase or third phase? Which phase I have to try hard? Which phase I have to try hard? Priyansi, it will be available, beta, don't worry. I'll release it Instagram, Priyanshu. I will give it to you in Instagram. Third phase, super Sudarshan. So that means what? I hope you might have understood the story. First, second, third. In the third phase, the energy giving means it will be quite difficult too. So explanation will be, when first electron is ejected from an atom, the nuclear charge increases due to decrease in number of electrons. This is what I told you in the simple story, that the nuclear charge remains the same, but every time when you are taking out one electron, the nuclear charge is becoming more effective, which will not allow the release of another electron. So to maintain a balance, you have to give more energy. To maintain a balance, you have to give more energy. Every time you have to keep on increasing the energy. Fourth case not possible. Fourth case not possible. Maximum 3, Sudarshan. After that, fourth case will be like bone. It will be like a bone struck here in the neck for the atom. Okay. So now electron affinity I am going to talk about. So what is the time I have? Another class. Ayo. Electron affinity is left. Electronegativity and diagonal relationship. So I'll just take 5 minutes extra and I'll explain this point. Okay, I'll try to finish this one today so that I will start heredity and evolution. Heredity and evolution PDF is ready. Okay. Now look here. Electron affinity. If somebody will talk about electron affinity, then we have to first think about what is affinity. Love for something is affinity. Simple way. Love for something is affinity. In simple way, I am saying that if I love chocolate, I will say that, you know what, if I want to eat chocolate every time, I will say that, you know, my affinity for chocolate is very high. Every time when I see chocolate, I feel like eating it. Means I am more having affinity for chocolate. I am having more affinity for what? Chocolate. So same thing happens here. It is the amount of energy released when a neutral isolated gaseous atom accept an extra electron. So what happens? Affinity case. Affinity case, a simple case is there, and that case is ki if my affinity for electron is more, then I will take electron. But beta, when I am taking electron, in return I have to give energy. In return I have to release energy. So what I have learned in the previous case? In previous case, if I want electron, I have to give energy. If I want electron, that was called as ionization energy. So if I was wanting electron, I gave energy. Now here, if I want electron, I gave energy. But here, if I am giving electron, I will take energy. Means here, simple concept is ki if I am accepting one electron inside me, then I have to release energy for stability. I have to release energy for stability. The concept is this only. That is, it is the amount of energy released. It is the amount of energy released when a neutral isolated atom can accept an extra electron to gaseous negative ion. So that is that it time it is making an anion. It is what making beta? It is making an anion. So now let's see, greater the amount of energy released, higher is the electron affinity. Greater the amount of energy released, higher is the electron affinity. And you have to understand one thing, time of I understood, Mahesh. Mahesh, I'm coming. Just 1 minute. Last one point, beta. You know what? Among fluorine and chlorine, chlorine is having most electron affinity. This is a very well-known CBSE question. Question is, which one is having more electron affinity? Chlorine or fluorine? The answer is chlorine is more electron affinity is there than fluorine. In next period, in next class, when I will give revision, that time I will finish electron affinity, but you just have to understand that acceptance of electron and release of energy is electron affinity. Release of energy is electron affinity. Now, fluorine and chlorine, they are taking electron very easily. Chlorine, fluorine, halogen family, they are taking electron very easily. But when they are taking electron, they are releasing energy also. But the one who is having strong electron affinity is chlorine. Why? Because bigger size of chlorine is there. Now fluorine and chlorine, if I am going to compare fluorine and chlorine and its electron affinity, both want electron. Fluorine is also wanting electron. Chlorine is also wanting electron. But here the problem is, when fluorine will take one electron in the outermost orbit, due to its small size, electron repulsion will be more. But when chlorine needs an electron, chlorine knows that my structure is big. So this repulsive force will be nicely stabilized. So that means among fluorine and chlorine, which one is having more electronegativity? Which one is having more electronegativity? Come on, quickly tell me the answer, beta. Among fluorine and chlorine, which one is having more electron affinity? Which one is having more electron affinity? Absolutely correct, Akshay. Why? Because the size of chlorine is bigger. I repeat, In this PDF, I think this is not written. About chlorine and fluorine, I have not mentioned this point. So please just note down this one. In PDF, this PDF, it is not available. I'm just telling you the most important point about this section. So now chlorine, fluorine, which one is having more electron affinity? Chlorine is having more electron affinity because it can nicely compensate that electron repulsion because of its bigger size. I hope you might have understood this point. Then I am going to last point, and that is exactly called as diagonal relationship. So what is diagonal relationship here is that some group 2, period 2 and period 3, some of the element resembles each other, like lithium resembles to magnesium, beryllium resembles aluminium, and boron resembles silicon. This is called as diagonal relationship. This is called as giving more electron is not more electron affinity. Beta, affection for electron is electron affinity. Affection means here it is like you want one chocolate, but if you have to digest that chocolate also. So chlorine and fluorine both are wanting electron, but chlorine compensates that by releasing energy nicely, but fluorine, the moment fluorine will take, fluorine structure is small, so electron repulsion will start. So they both are having electron affinity, but chlorine is having more electron affinity. Understood? So now lithium will resemble magnesium, beryllium exactly, aluminium, boron, silicon, and this resemblance is called as diagonal relationship. Now diagonal relationship is responsible because of possible because of polarizing power. So I have not mentioned here some of the PDFs. I have not mentioned some of the points. I had no time to mention all these points to you. So it is exactly called as polarizing power. They have same property because of polarizing power. Polarizing means in simple ionic. You have to understand ionic potential. Other name of polarizing means ionic potential. Just remember this word, ionic potential. They have same ionic potential. Since they have same ionic potential, they have more or less same properties. Okay, so they behave similar. That's why it is called as diagonal relationship. Lithium resembles magnesium, beryllium resembles aluminium. So it is exactly called as polarizing power or ionic potential. Okay, so structure resemblance will be quite similar because of this property. Okay, so I'm going to keep it till here. Next class I'm going to start biology. Fine, bye beta, good night.